All right, good morning and welcome back. Today is the last new lesson of Chapter 7. Okay, so we're going to be talking about double angle identities. If we look on the back of our unit circle, so down here we have some double angle identities. You'll notice for sine, double angle means like multiplied by 2 for the angle if it's twice as big. And the double angle identities for sine, there's just one. For cosine, there are actually 3 different ones depending on what we are given. Tangent, we have 1, although we're not going to deal with that. So we're going to worry about these first 4, and depending on what we're given determines which ones we want to use. We're going to make it as easy on ourselves as possible. So on this first one, our end goal is to find cosine of 2 theta. We know cosine of theta is 8 over 21. So if we look here, we have cosine of theta. So of these 3 formulas, 1, 2, 3, there are 3 formulas. These first 2 require sine. We don't know sine, so rather than figure that out, let's just use the one that only deals with cosine. So 2 cosine squared theta minus 1. So we know it's going to be 2 times cosine squared theta minus 1. So 2 times, that's going to be 8 over 21, and both of those will be squared, minus 1. Now, if we think about this, 2 is the same as 2 over 1. 8 squared, 64. 21 squared, 441. If you don't have that memorized, that is fine. Okay, then we multiply here the fraction, 2 times 64, 1 times 441. I'm going to move over here, so that'd be 128 over 441 minus 1 over 1. Now 1 over 1 we can convert to 441 over 441, so we have the same denominator. And now 128 minus 441, that'll give us negative 313. And we are done. Now, on your next one, once again, you're finding the same thing. You're finding cosine of 2 theta. The difference is this time you were given sine. Last time we were given cosine, this time we're given sine. So if we look, instead of using the cosine one down here, we're going to use the one that just requires us to know sine. So it's 1 minus 2 sine squared theta. Okay? So 1 minus 2 sine squared theta. And if we look here, so 1 we know is still 1 over 1 minus 2 over 1 times whatever our sine squared is. So 2 over 7, but we got to square both of those. So let's keep going. 1 over 1 minus 2 over 1 times 4 over 49. Keep in mind PEMDAS, so order of operations matters. We need to multiply before we subtract. So we'll multiply. So 1 over 1 minus, it's going to be 8 over 49. Now 1 over 1, we can rewrite that as 49 over 49. It's the same thing as 1 over 1. We subtract that, we get 41 over 49. Double check if you can simplify, but 41 is a prime number and does not go into 49, so we are good. All right, now the final one on the front page here. On this one, we are trying to find sine of 2 theta. Now when we're finding sine of 2 theta, it doesn't matter, we only have one option, and we need both sine and cosine. So we have to figure out what sine is to help us with this. Now, as we said, it's going to be 2 times sine of theta times cosine of theta. So we have all this except sine. Now to find that, hopefully you guys remember, if we know that cosine, if our theta is here, hypotenuse is right there, our adjacent is right there, we need to figure out what is that side, that opposite side. And if we find the missing side, then we can solve this. So find missing side. And once we have this set up, we can simply check our Pythagorean triples on the unit circle. I don't know if you guys remember that, but we have that list. So pull out that sheet, take a look. Some of you probably have this memorized, but 3 and a 5, we know that missing side is 4. So there's a 4. If you're not sure what I'm talking about, over here on the unit circle, remember we made this list Pythagorean triples. So there was a 3 and a 5. The missing one's a 4. That will always be true on a right triangle with a side of 3 and 5. Okay. Now, the over here, so we have 2 times sine theta times cosine theta. And if we rewrite that, so that's 2 over 1 times our sine would be 4 over 5. Cosine, as it told us, is 3 over 5. Now to do this, just multiply across the top. So 2 times 4 is 8, times 3, 24. On the bottom, 1 times 5 is 5, times 5 is 25. And here is our final answer. You can check, can you reduce? But in our case, 24 over 25. If there's a difference of 1, there's never going to be anything more you can do to reduce. All right, so on to the back. Once again, we're doing the same thing, finding sine, except this time they gave us sine. Okay, it's the same approach. Still going to be 2 times sine theta times cosine theta. So I already have this first part, 2 over 1 times 15 over 17 times, what? So we draw our triangle. We know this is 17. Opposite is 15. I need to figure out what that is. Once again, 15 and 17. Look at your list. Pythagorean triple. 15 here, 17. There's going to be an 8. So that side we're missing is 8. I'll put 8 over 17. So we multiply across the top. 2 times 15 is 30 times 8 gives us 240. 1 times 17 times 17. You might remember 17 squared. That's 289. If you can't do these in your head, that's fine. Use a calculator. I don't mind. All right. So we got a few left. 2 left here. This next one, we are given sine again, but we're finding cosine of 2 theta. So once again, if we look at our choices, if we have sine and we're trying to find cosine, probably want to use this one, 1 minus 2 sine squared theta. Okay. You could use Pythagorean theorem to figure out what cosine is and then use either of these, but this will just be easier. One less step. Okay, so it's going to be 1 minus 2 sine squared theta. So 60 squared, 61 squared. Okay, so that's still 1 over 1 minus 2 over 1. Now these ones I couldn't do in my head. I already wrote them down though, just to save a little time. 60 times 60 gives us 3,600. 61 times 61, 3,721. And I guess maybe I should rephrase that. I could do it in my head if I wanted. You could probably do these in your head if you wanted, but it's fine. Use a calculator. You don't need to test yourself. You don't need to prove yourself. Okay, we multiply by 2. And now we can change 1 over 1 to have the same denominator. And once again, this gets a little complicated to do in your head, but use a calculator, that's fine. We'll get negative 3,479 over 3,721. All right. One final problem. This last one. Once again, we're finding sine of 2 theta. So you might remember, you might not if you have to look, but 2 times sine theta times cosine theta. So we need both of them. So if we need to find the other, the only way we can really do that is Pythagorean theorem. And on this one, we have our theta. We know that the adjacent 48, the hypotenuse 73. Okay, and We don't know what's over here. Here's the thing. This one, we look, it's not on our list. There's nothing involving a 48 or 73. Okay, so we're going to have to do it. A squared plus B squared equals C squared. Oops, I forgot. Square those. So 48 squared, 2,304. Once again, use your calculator. That's fine. Subtract that over, and we will find B squared to equal 3,025. Take the square root, and B equals 55. So if this missing side is 55, then we know that our sine is 55 over 73. Cosine is 48 over 73. If I want, I can put that 2 over 1. Multiply across, 2 times 55 times 48, 5,280. Once again, I did these in the calculator. You can as well. 73 times 73, it's going to be 5,329. And there we go. That's our answer. So that is all for Unit 7. If you don't have the sheet, you need to get one. So ask me about it. There's some orange ones sitting on my desk. If I'm not there, you can grab one. But hope you guys have a great day, and I will see you soon. Bye.